Alrighty, welcome to measurement. So measurement, we're always going to be interested in things like distances, areas, volumes, capacities, and also looking at different shapes. We're going to be looking at 2D shapes, we're going to be looking at 3D shapes, we're going to be looking at perimeters, we're going to be looking at all of these sorts of things. But to start off with, we're going to be looking at triangles. In particular, we're going to be looking at Pythagoras' theorem. And today we've got one goal, which is finding the hypotenuse. Alrighty, so let's talk about a right-angled triangle. So if I have myself a right-angled triangle, something that looks like this, when we talk about the triangle, we can notice that it's going to have three sides. That's just part of what it means to be a triangle. What we're going to be talking about, however, is then which sides are which. Now, the side opposite the right angle, so the right angle here is 90 degrees, which is a right angle. Opposite the right angle, we're going to find the hypotenuse. Now, the hypotenuse is the longest side. It is the longest side. It's always going to be the longest side. Now, the other two sides are the short sides. Now, sometimes the short sides can be the same length, but most of the time one of them is going to be slightly longer or shorter than the other ones. In fact, they can be quite different in lengths, but they will always be shorter than the hypotenuse. There's no way around it. Now, by convention, we label the hypotenuse with the letter C, and we label the two short sides with A and B. You can label it A and B this way, or you can label it A and B this way. It doesn't matter. These are both the short sides. One of them is A and the other is B. For those of you who like rules, A is going to be the shortest side, B is going to be the second shortest side, or the middle side. Your hypotenuse longest, C is the longest, A is the shortest. Okay? So this theorem here talks about the squares. So when we talk about that, it means that we can actually work out the length of the long side if we know both the two lengths of the short side. So let's have a crack at actually doing it. Alrighty, so imagine we see this triangle out in the wild floating around, and we wonder what is the length of this third side. So it's 10 centimeters on this side, it's 24 centimeters on this side, and the question is, what about the final side? Well, first of all, we know it's a right-angled triangle, we know two sides, so we can be using Pythagoras' theorem. Pythagoras' theorem is all to do with sides, so no angles apart from the right angle. Alrighty, well, smallest side is A, second smallest side is B, and without even looking, I know that this is the longest side because it is opposite the right angle. So C is the one we're interested in. So A is equal to 10, B is equal to 24. Let's substitute both of those facts in. We get C squared is equal to 10 squared plus 24 squared. Alrighty, using my calculator, I can work this out. It is 676. Now, lots of people get to this point and they stop, but we've got to remember that we're not solving for C squared, we're actually just solving for C. So what do? Well, this is the point where we take a square root. Now, the square root is just a button on your calculator. Hopefully, you'll be able to find it. And in this case, the square root of 676 is going to be 26 centimeters. Now, the reason we know it's centimeters is because it's a distance, right? It's the length of this side. And because the other two units were both in centimeters, we know the answer is going to be in centimeters. Let's look at one more and then we'll move on. Alrighty, let's have a look at this triangle. So this triangle here has got 0.6 kilometers along this edge and 800 meters on this length, and so we are looking for the third side, which is once again the hypotenuse. So this is definitely going to be C, this is A, and this is B. But most of you should be alarm bells are ringing. Why? Units are not the same, and we cannot do any of this sort of maths unless the units are all the same. So we've got to make a choice. Do we want to find everything in kilometers or in meters? In this case, let's get rid of the decimal. So I'm going to convert 6.6 kilometers into meters. We do that by multiplying by 1,000, which gives us 600 meters. And now, using Pythagoras' theorem, c squared equals a squared plus b squared, I know that A is equal to 600, and I know that B is equal to 800. Substitute both of those in. 600 squared plus 800 squared is equal to 10,000? Not 10,000. Should be 1 million. C is then equal to the square root of 1,000,000, and therefore C is equal to 1,000. What units, you ask? Well, 1,000 meters. Why? Because the two units we put in were both in meters. If they had been in kilometers, then our answer would have been in kilometers. Alrighty, so that's a little bit of practice on finding alongside. See you in the next one. Goodbye.